All right, welcome to our fifth unit of Unit 8. Oh, it's right there, that's awkward. This is Introduction to Reaction Mechanism. This is our first of two honors sections. They're really just one concept split in two videos. But if you're general watching this, don't worry about it. You're welcome to, but you're not going to be required to know it. So, balance equations are helpful, but they really don't give us enough information to actually determine the rate of our reaction. They give us an idea of what happens in an equation. For example, let's pretend that somehow we have an equation where we got A and 2B produce C and 3D. That tells us that for every one A, we're going to need 2B. Now, pretend whatever compound they are. It doesn't, however, give us an idea of how quickly they react. For example, while we are using more B and you think that you would need more B to actually react, maybe A is really, really hard to react, and it's a lot easier to get B to react. It doesn't give us any idea of the properties of the compounds or how quickly / easily these come together. So we need a bit more information to actually get a rate law just from a balance equation. Now, most chemical reactions actually occur in multiple steps, even though the balance equations really just seem to imply one step. Like in that previous equation, where we have A plus 2B produces C and 3D or something, it kind of looks like, all right, you start with A and 2B, and a few seconds later, you've got C and 3D. While sometimes that may happen, a lot of them actually have maybe some partial state in between, like an E or something, that's kind of there and kind of goes away. It's like multiple steps, basically, which, again, makes it hard to get rate laws from our balance equations because we're kind of missing half the steps at times. So, a reaction that occurs actually in one single step is called an elementary reaction. Now, this is definitely a useful term. It's used quite a bit in what we call reaction mechanisms. And especially because then you can look at most reactions as consisting of just two or more elementary reactions. So elementary would be if basically if A is producing B and there is no step in between, it literally is one point it's A and now it's B, that's elementary. If it's A into B and then later on A to C, then our reaction from, well, let me show you. Let me kind of actually reword that a bit. So if we have a reaction that goes from A to B, and that's it, then this we could call elementary. But let's say we have a reaction that says it goes from A to C. Maybe that's actually not quite true. Maybe we actually have A first actually goes to B, and then goes to C. So that, yes, overall, A technically goes to C, but that's not really like the full story. So each of these would be considered an elementary reaction. So, and then A going to C consists of two elementary reactions. This is actually what normally happens. Though there are many that actually do just go one reaction like that happens. A lot of them are in multiple. So, the series of elementary reactions that actually take place during a complex reaction is called the reaction mechanism. Like in that previous one where we said instead of just going directly from A to C, we went from A to B to C. That list of going from A to B and then B to C would be like our reaction mechanism. It's a list of basically all the steps that happen in a reaction. Okay? So using energy profiles, these things, we can see how reactions occur in multiple steps. We can also see what we call the transition states and the intermediates that actually form in a reaction. Now, let's kind of talk real quick about what those actual terms mean. So, a transition state is an unstable arrangement of atoms that forms for a moment during the reaction. These are represented as peaks in an energy profile. So a lot of energy profiles look something like this. This means that this and this are representing, these technically, represent transition states. You probably won't actually see these in a reaction. It's kind of weird, but if you actually were able to follow step by step in a reaction, you actually won't see these. They're not stable enough to actually be labeled. They're unstable. They're kind of a transition state, which means a state in between others. Now, you may have guessed it, you can actually see the bottom ones, but transition states you can't see. Again, though, they are representing by the top part. So this, by the way, has two transition states. An intermediate is a product of one elementary step, but a reactant in a later elementary step. So that means that this is like that B in the original equation from a while ago. It's not really part of our final reaction, but it is an actual step in between these. These are represented as the troughs in an energy profile, which means this is an intermediate. So in this reaction, there's one intermediate. Now, these often can be labeled. You can find these. They may be very brief, but you often can actually label them. You can see that, all right, this is basically a part of our reaction. It's just not part of the final. So when you're writing your balanced equation, these won't show up because they're not really part of a reactant and they're not really part of a product, but they are an actual integral part of it, and typically a reaction mechanism can show them. Okay, so on the energy profile provided, well, here you go. Label the following: reactants and products, all transition states, all intermediates, and our activation energy. Now, I'm going to put an axis up here, and for some reason this graph looks crooked. Draw that on your paper, spend a few minutes labeling these as best you can, and then come on back and I'll have things labeled. All right, so reactants, products, 3 transition states, 2 intermediates. Sometimes they'll actually give you the equation of them. This time we don't. You're just labeling where they would be. And our activation energy. And that at least gives you an idea of what energy profiles look like. Our next video will talk more about reaction mechanisms, but this gives you kind of the final bit of information that you can see from energy profiles. Thanks for watching.